So I'm going to introduce 3 new symbols today for our new section, and I'm going to follow the same color scheme that I've been following for new symbols previously: syntax, semantics, and formalism with these colors. So let's start with syntax. So for all of these symbols, the way they operate in terms of grammar is that you stick a term on either side, term here, and overall what you will have is a term. So what you have in the end is not something that can be true or false. It's not a proposition, it's a term. This one is referred to as intersection. This one is union. And this backslash symbol, not a forward slash, a backslash, is a relative complement. Okay, and the grammar for all of them is basically the same. You put term on either side and it gives you a term. Okay, and there's more to say about semantics. There's more to say about what these ways of thinking about what these mean, but actually it's easiest probably to just get at the formalism immediately. We've sort of reached the point where once you see the formal definition of something, it pretty much does explain to you what is the intention. So if I take A intersection symbol B, then that's going to be defined to be the set of things that are in both A and in B. So this is the membership condition for being in this set. To be in this set, you must be in both A and in B. Notice the difference between these two symbols, this symbol and this symbol. They look kind of similar, but something very different is going on here versus here. This one is joining two propositions together, right? And we read this as and so overall here, like, this is a proposition. It says something. It says that X is in A. This says X is in B. This says that both of these are true. X is in A is true and X is in B is true. You cannot think of this way. This is joining two objects to create a new object, right? This is a collection of things. It's a set. This is a collection of things, and this is a collection of things. So this quarter, we actually will not have any trouble with this since you guys are using LaTeX for everything. But in previous quarters, I would always warn people to be very careful in their writing about distinguishing between these two symbols, with making this one extra pointy and this one extra curvy. For you guys, you just need to know the LaTeX. And actually, maybe we should have a fourth item for each symbol we introduce, which is the LaTeX. So that symbol will be cap. This one, the union symbol, this is cup. And this one, the relative complement, is set minus, which suggests to you what it might mean, but we'll get into it in a moment. Okay, now for the union. So when I write A union B, that's going to be defined to be the set of things that are either in A or in B. So to be in the union, you must be in at least one of the two sets that are being unioned. And for relative complement, to be in the relative complement, the membership condition is you have to be in the left-hand set, A, and you have to not be in the right-hand set, B. Just like that. Okay, let's get into the semantics of each of these. So I've said how to refer to them, but here's what you might imagine. So let's say you've got two bags of stuff, and you intersect them. Then what we imagine is that you get another bag of stuff which consists of only the common elements. So if this one has, say it has a flower and a smiley face and the number 3, and this one, if you look inside, it's got a flower and a number 2 and a triangle and a smiley face, then what does it take to be in the intersection? You have to satisfy this condition, where by u I mean x. So in order to be in the intersection, you have to be in both the left-hand set and in the right-hand set. So who's in both? Well, the flower and the smiley face, and that's it. So that's the idea. And what if you were to union these same two sets? So let's say you were to union them. Well, to be in the union, you just have to be in at least one of the two sets. It's an or, right? So, for example, 3 is in the union because it is true that 3 is either in here or it is in here. That's because it's true that it is in here. So, you just end up putting everything together. I guess that's everything. And then for relative complement, if I were to take the relative complement here, then to be in the relative complement, what do you have to do? You have to be in the left-hand set and not in the right-hand set. So the things in the relative complement are the things that are in this bag, but not in this bag. So for example, the number 2 would not be in the relative complement because it fails to be in the left-hand bag. So this part would fail. The flower would also not be in the relative complement because while it is in the left-hand bag, it fails to not be in the right-hand bag. So you see the flower here. So what's in the left bag but not the right bag? It seems like the number 3, and that's it. So the relative complement is selecting some of the things in the left-hand bag and putting them in the resulting bag. It only selects those things that are not also in the right-hand bag. Sometimes it's called set subtraction, which is why the LaTeX symbol is like that. It's as though you're taking this set of stuff and, well, it's as though you're taking this set of stuff and then subtracting from it anything that was in that set. Okay, so looking at the notes, what I've introduced here is definition 28, and I've also introduced definition 33 at the same time. Now, if you imagine bags and objects in bags, you're probably going to have a lot of intuitive ideas about what happens when you combine these symbols in different ways. And that's really good to have those intuitive ideas. But remember that while those can help you decide what it is you should try to prove and what you should probably not try to prove, actually coming up with a proof, you're going to need the formalism. So you're really going to need to use the definitions and allow yourself to use the original definitions. So that means using Axiom 5. That's basically what this entire course is about, is repeatedly using Axiom 5 with set theoretic definitions of things.